We're going to revisit section 1.7 to take a look at quadratic and rational inequalities. To solve quadratic inequalities, you first want to solve the corresponding quadratic equation, which means just suppose that there's an equal sign here, and then do what we have done several times in the past. For example, factor, and this factors into 3 and 5, that makes 15, with a negative on the 5 and a positive on the 3. So x minus 5 equals 0 gives x equals 5. And x plus 3 equals 0 gives x equals negative 3. So now is where it gets a little different. We're going to draw us a number line, locate our two solutions, negative 3 and 5. Notice how this divides the number line into 3 separate pieces. Now we need to know, so which pieces get shaded, which ones fit the inequality. So the rest of the problem is a matter of just choosing a number and seeing if that number works. For example, if we choose a number in this region, something to the left of negative 3, such as maybe negative 4, that would give, in the original inequality, a negative 4 squared minus 2 times negative 4 minus 15. Negative 4 squared is positive 16. Negative 2 times negative 4 is positive 8. 16 plus 8 is 24. And 24 minus 15 is 9. So we want to know, does that work? Is 9 less than or equal to 0? And the answer is no, that does not work. So the left side of negative 3 is not part of the solution. We're going to take a number in between negative 3 and 5, any number in that region, and do the same thing. By substituting it into the quadratic equation, we'll determine whether or not it is part of the solution. For example, 0 is in between negative 3 and 5. 0 squared minus 2 times 0 minus 15 is very easy to calculate. That's just a negative 15. Is that less than 0? And the answer is yes. So that is part of our solution. Now I'm going to shade here in between the negative 3 and the 5 because that's part of the solution. Then we're going to take a number to the right of 5 that's in this region, such as a 6, and substitute 6 squared minus 2 times 6 minus 15. That's 36 minus 12 minus 15. 36 minus 12 is 24, and 24 minus 15 is 9. And we've already determined 9 is not less than 0. So the only region that fits the solution is the numbers between negative 3 and 5. Now the last order of business is to determine, is either of those part of the solution, talking about the negative 3 and the 5. If the inequality sign has the line under it, then they are part of the solution. I'm going to put a solid dot there. There's going to be times when you're going to be asked to draw the graph of the solutions. Just remember, you got either solid dots or open circles. These are solid dots. Now, the interval notation that you'll have to write for the solutions goes like this. We're trying to describe the shaded region. -3 is the number on the left, 5 is the number on the right. They are included, so they get brackets. And so that's what the solution looks like. Now, since we've already done quadratic equations numerous times, I'm simply going to say, just like with the first one, if this were an equals, I would solve the quadratic equation 3x squared minus 11x minus 4 equals 0. Now, as I mentioned, you could do this using the quad program on your calculator if you have such a thing. However, I come up with a 4 and a -1/3. The rest of the problem is what I really need to show you anyway. Here's the number line. Here's -1/3 and 4. If I test a number to the left of -1/3, such as -1, that would be 3 times -1 squared minus 11 times -1 minus 4, which would be 3 times +1. Negative times a negative is +11. 3 plus 11 is 14. 14 minus 4 is 10, and that is indeed greater than 0. So this region is part of the solution. We will shade here. We need to test a number in between -1/3 and 4. As in the previous problem, you know I like using zeros because the calculation is real easy to do. That comes out -4. However, that is not true. -4 is not bigger than 0. So let's try a number to the right of 4, such as 5. So that's 3 times 5 squared, 11 times 5 minus 4. So that's 25 times 3, 75. 11 times 5, 55. 75 minus 55 is 20. And 20 minus 4 is 16, which is greater than 0. So we will shade the region to the right of 4. As I said in the previous problem, the symbol here, since it does not have the line under it, is an open circle. To write the interval notation, the left side of this shaded region is -infinity. The right side of this shaded region is -1/3. There's parentheses on both sides. For this shaded region, the left side is 4, the right side is infinity, and there's parentheses because of the open circle. A U symbol stands for set union, goes in between those two. So that's what the solution would look like. Now, to solve the rational inequalities, we really need this to be a 0. So we will start by subtracting 4 from both sides. If we take the 6 over x minus 3 and subtract 4, we get the 0 that we wanted. Now we need to put the fractions together on the left-hand side, which means we need to get a common denominator and add them together. So we'll have an x minus 3 on bottom, 6 minus 4x and plus 12. That's minus times minus. So in the top, let's simplify it a little bit. That comes out to be 6 plus 12, or 18 minus 4x. Now, when you get the 0 here and a single fraction here, the steps are pretty straightforward. Some of the problems you'll encounter will already be like that. So you'll pick up from what we're about to do. And what we're about to do is simply take the top and the bottom individually and set them equal to 0. So finish solving. Move the 4x over, and we've got 18 equals 4x. Divide by 4, and we've got x equals 18 fourths, or 9 halves. Move the 3 to the other side, and we've got x equals 3. Now we pick up with what we just got through doing for the quadratics. We draw us a number line. We've got a 9 halves, that's a 4 and a half, and a 3. So the 3 would be here, the 9 halves here. And do you see, this is again divided into this region, and this region. We need to choose a number in each region to see if it works in the original inequality. So to the left of 3, somewhere out in here, I'll use a blue marker, is a 0. If I plug in the 0, I get 6 over 0 minus 3 is greater than 4. Well, 0 minus 3 is just negative 3. 6 divided by negative 3 is negative 2. So is negative 2 greater than 4? No, it's not. So I'm not going to shade that orange region. In between 3 and 4.5, the logical choice would be a 4. So 6 over 4 minus 3. I want to know, does that come out larger than 4? 4 minus 3 is 1, and 6 divided by 1 is 6. Is 6 greater than 4? Yes. So we need to shade that region. We finish out by trying a number to the right of the 9 halves. Now that's 4.5, so we could use, say, a 6. So if we do 6 over 6 minus 3, we want to know, does this work? 6 minus 3 is 3. 6 divided by 3 is 2. So is 2 greater than 4? And so the only shading is there in the middle. Now one last tidbit of information that is specifically unique to rational inequalities is this. Because the bottom of this fraction is an x minus 3, we know that x cannot be a 3, or we'd have division by 0. And so, regardless of what this symbol is, the 3 has to have an open circle. However, back to what we've been saying all along, and that is, because this is greater than with a line under it, the 9 halves gets a solid dot. And so the interval notation for this would be 3 comma 9 halves, parentheses on the 3, bracket on the 9 halves. Now this one has the same idea as the previous one, because there is a 4 here, we want to begin by subtracting the 4. So that would be a 3x plus 1 over 2x minus 3 minus 4. Now again, you saw what we just got through doing. We need a common denominator. So we need a 2x minus 3 here. So this comes out 2x minus 3 and 3x plus 1 minus 8x. That's negative 4 times 2x. And negative 4 times negative 3. And so 3x minus 8x is negative 5x. 1 plus 12 is 13. And just like in the previous one, we take the top and the bottom, set each of those equal to 0, and finish solving. Now I'm going to go through this kind of quickly. And the other one. Here's my number line. Now 13 over 5 would be 2 3/5. 3/2 is 1 1/2. So the 3/2 goes here and the 13/5 here. To the left of 3/2 there is a 0. When we substitute a 0 into the original, we get 1 over negative 3. Is that less than 4? Yes. So we need to shade there. We take a number in between 1 1/2 and 2 3/5. The only number in that region that I particularly care for is the 2. So 3 times 2 plus 1 and 2 times 2 minus 3. Is that less than 4? That's 6 plus 1 is 7. 4 minus 3 is 1. Is 7 less than 4? That would be a no. So we do not shade that region. This again is 2 3/5, so I could use a 4 and have 3 times 4 plus 1, 2 times 4 minus 3. That's 12 plus 1 is 13. 8 minus 3 is 5. That looks familiar. Is 2 3/5 less than 4? Yes, it is. So we need to shade that region. Now, as before, looking at that bottom, the 2x minus 3, that's what gave us the 3/2. The 3/2 has got to have an open circle, regardless of what the other one has, because it's on bottom. However, you notice here we don't have a line, so the other one gets an open circle also. So there's the graph of the solution. The interval notation would be negative infinity, comma 3/2, and 13/5, comma infinity.